slides. So once again, welcome. So in this presentation, we'll discuss how we can integrate Snowflake data with Microsoft Fabric, and we will explore the benefits of integrating these two platforms. The differences in their underlying data and formats will also be talked about, and the different methods for accessing external data in Fabric. So basically, the assumption for this webinar is for people that are already comfortable with Snowflake, but they have read about Fabric and they want to learn more and not necessarily migrate all their data infrastructure to Fabric, but take advantage of the Fabric features, but while keeping the Snowflake footprint that they already have. So our agenda for today. So we'll talk a little bit about iLink Digital, then we'll do a brief overview of Fabric and of Snowflake. We will talk about the storage formats because it's one of the main highlights that we have for this integration to be seamless, and then the integration options that we have. And as I said, the Q&A, please feel free to post some questions. I will try to answer them all as possible, but just leave them on the chat. So a little bit about iLink. So iLink is a global digital transformation company. We've been around since 2002, so 20 years more or less, and we pride ourselves of our customer satisfaction score. So we are present, we have a big presence in the US and also in India and Middle East and Asia. We are starting our integration, our partnership in Europe. So we have offices in Lisbon and also currently in Zurich, and we have more than 3,000 consultants globally. We have been Partner of the Year in terms of the data and AI business specifically. We have been Partner of the Year in the US twice in a row. We have also been working with Fabric since private preview, so it was called Trident at the time, and we have been a recognized solution partner in different specialties like data warehousing migrations, analytics, AI, and machine learning. So we cover everything from various, from the data engineering to the business analytics and reporting, and also the enhancements with AI and machine learning and all of that. So basically, we provide end-to-end, which is a very relevant way of working for a platform like Fabric. Also, we are a Snowflake partner, and we can also cover that part. So over here, you can also see that we work with some customers that are not only based part of the Fortune 500 in North America, but also across several verticals like retail, healthcare, life sciences, manufacturing, and so forth. And we are partners with the main core technology. So Microsoft is one of the main ones. We also already talked about Snowflake, but also Databricks and other complementary technologies like Kafka and those technologies. I don't have a slide about myself, but my name is Miguel Felix. I'm a BI architect at iLink, and I develop the projects inside the Fabric workspace. So providing insights about what are the best practices, how can we develop the models inside the Fabric workspaces and all that. So integration of data, all of that type of questions. That's what I do mainly in all sorts of business. So, but what are we talking about today? What will we cover overall? So first, we will explain why Fabric and Snowflake work well together. So these are two powerful tools that provide a better understanding of your data through the warehousing capabilities of Snowflake and the data integration and analytics at Fabric side. And then we will delve a little bit into the differences in data formats, between Fabric and Snowflake. So although they support the same data formats by default. There are some differences that we need to understand so that the integration and the collaboration between both tools is available. And then we will explore different methods for assessing the external data through Fabric. Having a little bit talk about the Power BI Direct Query, the shortcuts and the mirroring. So some of the options that Fabric has available, not only for Snowflake, but also for other tools that are inside Fabric. But in this case, let's focus in Snowflake. So why do we talk about Fabric and Snowflake together if you already have an investment in Snowflake? So basically, Fabric changes the landscape when it appeared. And many organizations that have invested in Snowflake looked at it in a different way to take advantage of some features that Fabric has and that Snowflake does not have. So these two platforms working together will make a powerful platform to make your data capabilities to the next level. So Fabric provides a unified view of data across the organizations, while Snowflake provides a scalable cloud-native data warehousing. So together they can provide different options and a way for you to have analyzing and processing your data in a more effective way. So, but let's start by looking at what is Fabric, what are the main core options that we have in Fabric, and then let's also talk a little bit about the Snowflake. So we assume that people that are already comfortable in Snowflake. We are not getting into a lot of details about Snowflake. We want to focus more on the Fabric side because this is the big plus that we can bring to your businesses, and that you can take advantage of all these new features that Fabric comes. So, but and then we will also. It's always needed to talk about the Snowflake part, of course, but we will not go deep into that. So, but Microsoft Fabric is an end-to-end analytics platform that provides a single and integrated environment for all data professionals, and the business to collaborate on any data projects. So Fabric provides a set of integrated services that will enable you to ingest, store and process your data in a single environment with a single experience. So you have not only tools that are available to the professional data professionals, but also to citizens. So to everyone in your organization can integrate the tools that we have in Fabric to make analysis on the data. So if we look at the platform of Microsoft Fabric, we can see that it's a scalable, that the scalable analytics can be complex, sometimes fragmented and expensive. With Microsoft Fabric, the idea is to combine all the various services that we usually have from different vendors into a single one. So the idea is not to have everything in different parts, but to have a single product that is as easy to understand, that is as a single setup experience, it's easy to manage, and that is a persona optimized experience and tool integrated user interface. So in addition to having a simple and shared user interface and experience, Fabric is a unified SaaS, so a software as a service, with all our data stored in the open format on the OneLake, and that is accessible by all the analytical engines, so the top layer that we have over here. But on top of that, it also offers the scalability and the cost-effectiveness that people want with the internet connection. So basically, we have over here some services that Fabric allows you to have. So we start with Data Factory, so integration combining Azure Data Factory to move and transform data with Power Query for those that are not so used to that experience of Azure Data Factory. So as I said previously, to the citizens and also to the professional developers in data. We also have the Synapse data engineering, so using Spark platform for data transformation at scale. Then we have the warehousing with SQL performance and scale to support data use, and data science for machine learning and Spark modeling training. And in the end, we have real-time intelligence with real-time analytics to query and analyze large volumes of data in real time. The last one that we see over here is Power BI, that is the business intelligence to give the visual aspect of all your data. So as you can see also at the bottom, we have two main things. We have the AI and the purview. So the AI is currently the co-pilot that is being across all the Fabric workloads, and also the One Lake, as I said previously, that's where the data is stored. So going into detail into the One Lake. So apologies. So the One Lake is the underpinning storage for Microsoft Fabric. So it is built on top of Azure Data Lake storage and supports structured and unstructured data. So you can have multiple formats like Delta Parquet or CSV JSONs, but you can also store videos, MP3s, and all of that. So images, everything that you manage. So the preferred storage format when we are talking about data is Delta Parquet due to its various features. So it's very efficient on handling big data. It has ACID, so it allows for you to have ACID transactions, so that are consistent, that are isolated, that are durable, and it's also very a very great way to have a file management that is scalable and more. So let's think about the One Lake as the OneDrive for data. So as you store all your Word documents and all your Excels and videos, all of that you want to have, and then you want to share with your organization. If you are talking about a data platform, an analytical data platform, then let's look at One Lake as the way to see what we have in terms of our data. So so this is the foundation of the Fabric in terms of the data layer, the One Lake. I'm not sure if we have any questions, not yet. Okay, so let's continue. So in terms of the Microsoft Fabric, we are going to talk a little bit just high level, these four premises of Fabric. And these are the ones that we are going to look into in terms of our presentation. So we already talked a little bit about the SaaS platform, right? Everything unified under one roof, so all the workloads, and something that is secure and governed. So one of the important aspects inside the Fabric infrastructure is the governance and the security that is the same across the different layers of Fabric. This means that you don't have to go to different experiences, to different options to have this secure. So when people enter, everything is set up in a way that is the same way for all the platforms. Then the lake-centric, the one that we already discussed in the previous slide. So the One Lake is the base of the data storage, and it's open to every tier inside Fabric. And then the Fabric wants to empower every business user. So it has a very familiar and intuitive layout. It's built into Microsoft 365, so people are used to that look and feel, to that user experience, and then it incites people to action. So the idea is to have a full integration with your data so that you can act upon your data and not just react. And then, as it's very common currently, Copilot is going to be an accelerator in terms of development of this tool and of your insights inside your data. So it's also a foundation on which Fabric is set upon. Okay. So concerning Snowflake, so Snowflake is a cloud-native data warehouse that provides scalable and secure data storage. So it will allow users to store and process their data, and this can happen in a very broad format of a variety of formats and languages, and it will and Snowflake provides a powerful platform for large amounts of data. So it's a very good complement to Fabric, because this brings the large data into the picture. So Snowflake started, if I'm not mistaken, back in 2012, and it's also a SaaS platform, so a software as a service, and this provides a single platform for data warehousing. So not only data warehousing, but also data lakes, data engineering, data science. So all of those types of things that you have around data, all those personas that you have around data are available also in Snowflake. This is a very secure way of sharing and consuming your data in real time also. And Snowflake's features out of the box, like the separation of storage and compute engines. So the data sharing, the third-party tools support, all of that, and allows for you to have a big demand on growing enterprises. So yeah, basically it's a good tool for storing your data in terms of the warehouse, and especially large data sets. Just one thing that while we were preparing this presentation, one thing that we discovered was that Snowflake comes from the fact that the two founders were had a common interest in skiing. So they came up with the name Snowflake because of that interest that they have. Okay. So we have a question: why use Snowflake to store and provide data if Fabric also supports that natively? What is the added value for using Snowflake and not doing it all in Fabric? So the idea over here, Michel, is the other way around. So we are talking mainly about people that already have Snowflake in place, but want to take advantage of the Fabric features. So we are not telling people to go, okay, I don't have any data analysis, any storage analysis or warehousing on my organization, and should I choose Snowflake or should I choose Fabric? No, that's not the question. The question over here is the other way around. So the organizations that already have the Snowflake in place and want to take advantage of all the technologies that Fabric will allow. Okay, hopefully that will bring some light into your question. So yeah, but they are very similar. Of course, as I said, the large formats and the data warehousing that Snowflake already has brought to the table, it has a lot of already organizations using it. So we need to take advantage of both sorry, apologies. We need to take advantage of both tools to get to the next level. So although they both bring powerful data capabilities, they use different underlying data formats. So and to get an effective integration strategy between these two, we need to understand what are the differences. So both of them can store data in other formats. So as I said, both are available for large volumes of data, and they both also support real-time data processing. But as you can see, so Fabric uses the Delta data format that is optimized for this performance and scalability to handle these large volumes of data. And Snowflake by default uses a commular data format that is optimized for analytic workloads. It is designed to support complex queries and enable efficient data compression and storage. So also recently Snowflake is supporting Iceberg to their storage capabilities. So Fabric uses the Delta format. So sometimes people call it Delta Parquet, sometimes people call it Delta. They are very passionate about these terms, so please forgive me if I sometimes say Delta, if I sometimes say Delta Parquet, but they are. I'm always referring to the same format. So if I'm saying something incorrect, please apologies. So, but this Delta format allows a very efficient processing of large data sets. So Delta uses a combination of Parquet files and Delta logs to store the data, and this allows a fast querying and efficient updates. So Delta also supports the ACID transactions, as I said in the slide about the OneLake, and it's very reliable when we are talking about scalable data. Okay. So this is an image that we took from the Fabric notes. So it's a very, if you want to learn about Fabric and all its features, and you want to understand some of the particularities, please go to this one. And this is concerning the Apache Parquet format. So the format is an open format. So no vendor lock-in if you are concerned about this. And let's try to understand this Parquet format, and let's take it to the next step by understanding a little bit about Delta. So as I said, Parquet is an open source. It's based on a column store format, and if we compare this to the traditional databases, we can understand what is the main differences between this approach and the ones for the traditional one. So on the left side, we can see this customer CSV. So the data, when it's read, it's line by line. So in this case, we will read this first line, and then the first line over here, of course, is the headers. Then we would read this line to get our data. Then we would read this line to get our data, and so on. So if you want the sales by our premium customer, we would need to go line by line to understand which one is premium, and then take those values from that specific line. So this is the traditional approach. So we would move from row to row, and this is used heavily on a lot of formats, but it's not very performant when we are talking about analytic workloads. This is because in this case, we are not interested in specific rows. We are interested in understanding aggregations over many rows. So we don't want to have to read all the rows of our data and then do an aggregation of a sum, but we want to have a quick way of aggregating the data. So the Parquet files, the Delta Parquet files on the right, as you can see, are stored in columns. This means that if we convert this information to a Parquet file, it will be more efficient. Why? Because when we look at the same thing as we were looking at previously, so the sales by our premium customers, we will only look at that premium customer column and the sales. In this case, we have a category, but let's assume it was a sales. And it's much more efficient because we will only look at these two columns, and the rest will be forgotten for that specific calculation. So the aggregation, it's done already at the level of the column itself and not row by row. So this is much more efficient for analytics, and it also has in the backend, it also has all the metadata for the structure of the file. So in terms of compressed repetitive data, for example, like we see over in our premium customer, that is only ones and zeros, right? It's much more efficient because he will only look for the ones and zeros. He does not need to go for every row to understand which ones are ones and which ones are zeros. So that is the basic steps on the Delta format, but on the Parquet files. But if we look inside the Delta format, we have also the Delta log, as I told you. So Delta table, that basically that's where our Fabric stores the data. The Delta table is actually just a folder, but it's a very specific, a very special folder that allows for different data organized in different ways. So Delta table folder structure builds upon the typical organization of Parquet datasets, but it adds some crucial components so that the Delta Lake enhanced capabilities are available, especially through the transaction log. So a quick overview. So we have our data files. So just like the Parquet files, the data is stored in Parquet format. So the image over here on our left. And these files are organized inside directories. So this will reflect your partition. So if you decide to have your data stored by year and by month, you would have a folder for year, then a subfolder for January, February, March, and then your files inside those folders. So that will give you, and you could go to any level you want. In this case, I just went year and month. Then we have the Delta log part. So this blue one on the middle. So this is the art. This is the core of the Delta table. And what makes the difference between this and the standard Parquet data sets is that the Delta log directory contains all the transactions for that specific Delta table. So inside that directory, you'll find several JSON files that represent the Delta logs. And these Delta logs will allow you to understand what are the informations that were added, that were removed, that were the timestamp when it was done, the user that done it, all those types of things. So all your changes to your data are stored in this Delta log. This also has these checkpoint files, and these checkpoint files is as the number of JSON commits that we commit grows in the Delta log directory. Reading all of this to reconstruct the tables will be time consuming. So to optimize this, Delta every once in a while writes the checkpoint files. So this is basically Parquet files containing the consolidated information, the state information, and that will allow for that information to have all the data checkpoints indicating that it's consolidated. So the frequency of a checkpoint inside Fabric can be configured, but by default, currently it's set every 10 commits. So if you have new data coming, every 10 times you add new data or change your data, it will have these checkpoint files. And then we also have the directory and the partition metadata. So for optimized and reading and sometimes skipping some data, because that's what makes this format so efficient, is that you can skip some format, some data, because you are not reading all the rows in your tables. So the metadata is stored in partitions. As I said, you can have it stored for example, by year and by month. So you would have the information on this format. So the main difference between the standard Parquet files and the Delta tables, so the Delta Parquet files, let's say it like that, is the Delta log that we have over here directly. So this Delta log allows to enable the components of ACID transactions capabilities, schema evolutions, and other advanced features. Okay. So, but as I said, keep a note of this, aka Fabric notes. It can be very, very interesting to see these explanations in more detail. Okay. So while Databricks always writes open formats by default, Databricks and Fabric, Snowflake does not. Okay. All the tables in Snowflake are in a native proprietary format, unless you actively define each table as currently an iceberg on creation. So they are currently working with iceberg. So, but if you don't do anything, it will be their default, their proprietary schema. So that means that the default pattern in Snowflake continues to be import and export to work with other tools. So you import data to Snowflake and then you export data from Snowflake. So many people have talked about the import as one of the biggest Snowflake cost challenges. So because It's not only the question about storing your data, but also the time that it takes to do the copy paste, let's say it like that. So with open table formats, this can be avoided, but the default as they are still needs improvement. Okay. Snowflake utilizes a proprietary file, and you can see it over here, the ORC format. So optimized row columnar format, and is specifically designed for the efficient storage and retrieval of data inside the Snowflake platform. So this format optimizes data compression and column storage to improve the query performance and minimize the storage requirements. So I don't think we have any questions over here. No. Okay, let's move on. And Snowflake uses, as I said, they are starting with the iceberg format. So Snowflake, this iceberg format, which is designed for also scalable data storages, uses a combination of Parquet and Avro files to store the data, allowing it again to do a fast querying and efficient updates, and also provides that previous thing that we are seeing with the Delta Parquet of the schema evolution and making it flexible and adaptable to the data format. So Iceberg is also an open source table format. This was originally developed by Netflix to address challenges they encountered with their project, the Apache's Hadoop project. And after their initial development in 2018, Netflix donated the Iceberg to the Apache's Software Foundation, completely open source. So, so this went from a private project to an open source, and it remedies many of the shortcomings of the predecessors, and has quickly become one of the most popular open source table formats. So, yes. So Delta Lake, Iceberg, and UDIT, for example, all store data in Apache Parquet files, but they diverge in how they store additional metadata. So you need to be. So these are three types that allow you to store the data in different formats. All of them Parquet files, but then the metadata, the one that allows you to get more out of your data, is made in different ways. So this is a very long slide where you can see the differences between Apache, Iceberg, and Delta. We are not going in full detail about this, but as you see, there is differences in terms of performance and optimization. For example, Apache Iceberg is optimized for large scale queries with feature like metadata-based filtering and partition. Apologies. While in terms of Delta Lake, this offers a similar optimization with filters, with features like data skipping, Z-ordering, and file compaction. So a little bit of different options so that you can understand what is the main difference between this Delta Lake and this Apache. So let me just check if we have any questions though. Okay. So just a little bit of which one is the best. This depends, Len. This depends on the option you are using. I can tell you that the industry is moving to Iceberg also. So not only Delta Lakes, I can tell you that Fabric is working in a way to integrate Iceberg also into their options. So not only the Delta Lake options, but also the Iceberg. Currently, it's already reading information from Iceberg in the Snowflake, for example. So it's a question of options, a question of scalability, and also I think mainly is a question about the platform you are at. As I said, if you are on Snowflake currently, you can already store your data in Iceberg, but you need to manually override the default value. So you need to specifically say, so this will be stored in Iceberg. So plus and cons for both of them, but they are being adopted Iceberg mainly because it's the new kid on the block, let's say it like that. Iceberg is being currently starting to be adopted by many different other platforms like Fabric. As you can see over here, and this is just a short information that we have. So if we look at this, this was a small summary about what are the engine supports and the contributors percentage. So it's useful to look at the engine support for each one of the formats. So given that the primary reason to pick up an open format table is to minimize the lock-in, right? So there was a survey that was to support the 11 top engines. So this included Athena, BigQuery, Databricks, Flink, Snowflake, and so on. And as you can see, almost 3 times as many engines support writing Iceberg tables. So compare with the number of engines that support writing Delta tables. So the Iceberg is getting very quickly adopted by the industry. So and that is one thing that we need to take into attention. So and this is compared with the number of engines that support Delta Lake tables or UD, right? So every tool except Databricks, for example, supports reading from Iceberg tables. So everything except Databricks. If we look at the image on the right, we can see the code contributors. So and over here, being an open data architecture, we would prefer to see a low value of key contributors. So to back up the enterprise software companies. So let's say it like that. So as you can see, the only one that is mainly focused on community and has a value of lower than 25% is UDI currently, as Iceberg is around 40%, and then Delta Lake is fully sponsored by companies. So we need to be Databricks over here. As I said, always writes open formats by default. Snowflake does not, as they have their own proprietary format, as I said previously. So unless you define actively the Iceberg creation, it will be proprietary inside Snowflake. So this means that the default pattern in Snowflake continues to be import and export to work with other tools. So many people want to see this as the main cost challenge, as I said also before. So okay, so accessing data, external data through Fabric. So in Fabric we have mainly 4 ways of getting data. So we have the direct query and the import mode. We also have the Fabric data factory that can be used to copy data from Snowflake into a lakehouse or into a warehouse. And we also have mirroring and shortcuts. So all of these are different options to accessing your data that is on Snowflake to Fabric. Each one has its different particularities, but yeah, basically this is what we have. So let's look a little bit in terms of what happened to the connectivity options before Fabric. So before Fabric, Power BI had the import mode and the direct query mode. So the first one is very fast because when you click, when you open your reports, they are very quick to load. Why? Because we do a duplication, we do a copy of your tables, and then we read that from the Vertipack engine, and it's very fast. But it's latent because we have to do a refresh, and it's duplicative because you have to duplicate your data into the dataset. When we look at direct query mode, it's not as fast, it's slow in terms of comparison with the Power BI reports that are in import mode, because all your DAX queries are passed through the metadata that is stored on the dataset. So basically the relationships, the formats, and all of that. And then this is converted into SQL queries that are then sent out to the report. So this is real time, but it's a little bit slow. So as a summary, so import mode data is stored within the Power BI data set. Reports and visualizations are created based on that imported data, and data is typically updated using scheduled refresh. For direct query mode, Power BI connects directly to the data source without importing the data. Power BI sends the queries to the source directly through the semantic model and retrieves that data in real time. And these are some of the limitations that we need to take into account. So, but for Fabric, we have a new way of connect. So we, on top of the import mode and of the direct query mode, we have the direct lake mode. So the direct lake mode in terms of process is similar to the direct query mode. So we have our data set that only has the metadata. We are not duplicating our data. But in terms of our data is much more quick because it's compared with the import mode. In this case, instead of transforming the information into SQL queries, what we are doing is using the VertiPack to scan the Delta Parquet files and go to those specific columns. So this is very fast. It's not duplicative, and it's almost real time. So if we go back to our example of those sales per premium customer, what we would do while running the report was to go directly to the Parquet files and just pick up those specific files on the Parquet files. Okay. So looking into the advantages of Direct Lake and the combination with Snowflake. So to take advantage of this Direct Lake, we need to have data into our OneLake. This can be used, as I said, in different ways. One of the options that we have available for Snowflake is the Fabric mirroring. So this allows users to replicate their data from an external data source, in this case Snowflake, to a Fabric data model. This allows for us to have a centralized data model that can be easily accessed and analyzed. So this is scalable, it's very flexible, but this can be expensive because this will require to have additional storage and compute resources. So you are duplicating your data from the Snowflake, in this case, to the Fabric inside. So, however, this is not a problem in terms of how you set it up. Okay, so currently it's really is really working in a very easy way. So as long as your data is in some kind of open format, and sometimes the data is not in an open format, right? Databases are almost notorious for keeping that data also in a proprietary format, and we want to have it to bring it all data into the OneLake. So in this way, Fabric introduced a mechanism that is the mirroring, and that will allow you to do that replication without the trouble of you having to transform the data into an open format to read it. So all the process is done directly by Fabric, and you don't have to do any setup. You just need to follow the on-screen tutorial, just next, basically, and just select. Of course, there is some specific things that you need to do, but currently there is support for Azure, Amazon, Google, for example, also for Snowflake, as I said. So you can do for all of these features, you can do the mirroring. So the downside is that you have the copy of data. The upside is that this mirroring is near real time and it's very low maintenance. Okay, so this accelerates the process of the mirroring. So in terms of one thing that free mirroring storage for replicas, the question is that the replica that you will have on OneLake, you don't pay for it. So it's Microsoft is the storage part of this mirroring is not being paid. So if you have all of your data in the OneLake mirrored from another data source, you are not paying anything for not for ingestion, for storage. Okay, so it's just an option to give to the different users. So mirroring a Snowflake database. So it's very easy. So simply to set up that. So as I said, no storage costs because they are doing it for free. No ingress costs, and if Snowflake, sorry, apologies. And basically what we have is, when we do the mirroring, we have 3 items. So we have the mirror database. So that is the one that we have all the setups to define the tables we want to have. We have our, so this is the replication of your data on the OneLake. We have our SQL analytics endpoint. So that's where you can use an external tool or some SQL capabilities to check your data using the SQL language. And then you have your data package files in the OneLake, so, and your default semantic model that is for your Power BI report. So very easy thing to do. It's near real time because after you do the update on the Snowflake, it takes a few seconds, 1 or a few minutes, depending on the size of the data, to be replicated, but it's almost real time. Okay. And then I don't have an option. I won't show you this live, but this is basically the steps. So you go, sorry, apologies once again. So you go to a Fabric workspace, you create a new mirror Snowflake database. You just add your credentials for the Snowflake. It's very easy. And then after entering the server, the warehouse, and the connection info, you open the schema and you select what is the database you want, and you choose your table. So just that, you don't have to do anything else. If there is any errors with your data, that there is some of the columns that are not supported because there are some data types that are not supported, or if you don't have the correct if you don't have the correct permissions, it will tell you. It's very plain to see what is the problem, and you just need to configure everything correctly on the Snowflake, and this will be mirrored. Okay. Shortcuts. So shortcuts basically is a link to where you have your data stored. In this case, there is also shortcuts for Fabric, and this allows one thing, that is no duplication of data. So the data will be stored in the Snowflake in this case, but then we'll just read it direct from the Snowflake to our reporting. So it's easy to set up once again. And although they are easy to set up, they can be limited in functionality because sometimes, depending on the data analysis needs, since we are not doing anything to it, it can have some limitations. So, for example, we have some examples of what types of shortcuts we can do. So you can do internally, so from a lakehouse folder, or from a lakehouse table, or from a warehouse. You can also do it from KQL database. But externally, you can do it for Azure, data lake storage. We can also do it for S3 shortcuts. So there is a couple of options there. Also, in terms of the data, you can have several options through the shortcuts, as I said. So currently, these are the ones that are available. So Azure Storage, Amazon, Google, and Dataverse. That is the one from Microsoft that was already used. This is already being used for a long time, especially for the Power Apps and those tools, and also Power BI. So shortcuts allows for an instant link to your data that is already in Azure and in other clouds without any data duplication and movement. Okay. So I don't have any use case example in practice because we need to have a Snowflake server, but we were able to find a video from Microsoft, and I will be just reading the script. Okay, I apologize for that, so that we can see. This is a short video, will take around 2.5 minutes, but let's see what happens. Okay, and apologies because I will be reading the script that they delivered. Okay, so we have an organization that uses both Snowflake and Fabric, and they want to create a new data warehousing project in Snowflake for their customer program loyalty. They have a lot of data inside Fabric that they need to unify inside of this data warehouse so they can do all the analytics and reporting and other processes they want on top. So they have customer support, sales review, that all is going to do the analysis in the loyalty. So let's start with Snowflake and get started with our new project. So you see the option for using the iceberg tables over here. So we are going to store our data in the iceberg format. And with this, Snowflake is going to store all the data in this new format. I'm going to start by adding some data over here, and let's just add the members data, as you can see. And we can see indeed that the data is going to be stored in the Fabric one lake. So let's just check this. So let's go ahead and select some data to upload over here. So this is the Fabric, this is the Snowflake database, as you can see already in Fabric. And we are going to map some of the columns over here. So as you can see, it was, let me just go back a little bit in terms of the, so we are creating, let me just go back over here a little bit so that we can see. So over here we have they created the customer loyalty, they added the scheme, and they then added this to the one lake. So this is the Contoso loyalty program that they did, and that is already, as I said, it creates 3 different things. So it creates the mirror, it creates the SQL endpoint, and also the default semantic model. Okay. So and then, as you can see, we can create shortcuts into this Fabric item in this case, and we are able to pick up the information that we have from the Snowflake. So as you can see, it's a very transparent way of getting the data, and when we have new data from the Snowflake, we are able to get it on our Fabric in a single go. So it's a very easy way to get this information. In this case, we can then, on top of this, generate notebooks and all sorts of tools so that we can highlight your data. So basically, it's a seamless option between both of them. And as you can see, they are sharing over here also the option of getting the data not only from Fabric, from Snowflake to Fabric, but also then ingesting that data on the other tools, so like Excel and SQL Server and all of that. So, okay. So just a small summary on this before we conclude and go to our questions. So before Fabric, we had basically 2 modes of getting our data: import mode and direct query. In Fabric, we also have the mirror, in this case, mirror Snowflake databases. Coming soon to Fabric, there will be a support to iceberg format and also store Snowflake data in one lake. So this example that we were seeing was the store of Snowflake data into the one lake directly. So this is some of the future of Fabric and Snowflake working together. So without the need for us to have any special things to be done, okay? So basically, as a conclusion, integrating Snowflake data with the Fabric provides a powerful platform for analyzing and processing our data. But we need to understand the differences in formats, especially the question when, if we don't define the iceberg, for example, in the Snowflake, we may have some limitations, but we can also create without even the iceberg, we can create a mirror database and just ingest our data directly to Fabric, and we have a copy of the data. So we need to work together in both worlds so that we have an efficient integration strategy. Okay. So I just leave I just leave the context for iLink over here. Let's just check what are the other questions we have. So is it possible to migrate from one into the other one? So in this case, we are talking about changing the data from from the Snowflake to the Fabric, or from the Fabric to the Snowflake. So the idea over here is not to have that migration, is to have the integration of both worlds together. Again, both of them have pros and cons. Both of them are different platforms that will allow different things. One of the major drawbacks in terms of Snowflake, as I said, and that most people said, is the question about importing and exporting the data when you want to access it. So maybe depending on the size of your data, it's not a question about migrating, but it's a question about using both of them together. So, but using the open format, so the Delta format or the Iceberg format, it's much easier if you want to migrate it from one to the other one, yes. Is the schema evolution an issue for Delta Lake? It seems it has limitations. Yes, schema evolution can be a limitation, but as I said, Fabric is also working on getting the Iceberg that will allow that schema evolution to be in place. So hopefully in the future that will be more diluted in terms of the way it stores the data and the way it evolves your data. Okay. And then we also have a question from Michelle. So what is the Vertiscan? Why is it fast? So let me just go back to the import modes as we added. So over here, just a second. Okay, so we are talking about this part over here. So when we talk about the in this case Power BI Fabric reports, we on the back end there is the Vertipack engine. The Vertipack engine is a way, it's an option, it's a tool that is optimized to do DAX querying, in this case to transform DAX querying and to transform it using all the metadata that we have on our data and just transform your aggregations into the final result. So this is not a technical explanation, okay? I'm trying to make it a little bit more light, but so it's the engine that is behind. When you do any DAX querying, the Vertipack engine converts that query. So you pick up column A, B, and C, and that is transformed into a query. In this case, a DAX query or a SQL query, whatever it is. But in this case, the Vertiscan is when you go directly to the Parquet file. So we will pick up those DAX queries, and those DAX queries, if you go and read them, you will see that they identify all the columns that you want to analyze. As I said, the Parquet files are columnar based. This means that when you use this Vertiscan, you go directly to those columns and you are not going to anything else. So this takes advantage of the Parquet format and just picks up those specific columns, and it's much faster than picking up all the information row by row. As I said in the previous slide, let me just go back a little bit for you to make it a little bit. Okay, that's over here. So if we look at this file, the Vertiscan allows you to go directly to this specific line. For example, this line, but this specific column. Okay, this is the image is like a line, but this is column by column. Okay, the information is the column information. This goes to this specific premium customer, and the Vertiscan does only the scan of this is premium customer and your sales. For example, let's assume that this category is sales. So instead of going through all the files, so instead of going Abigail A's 409, let's see if this is, oh, it's premium. Amanda Clark, oh, it's not premium, and so on. The Vertiscan allows to go directly to these columns, and that is the main why it's fast, why it's more performant than doing the normal process, the traditional process. The same thing happens when we are looking at the import mode. The import mode, since we are doing the DAX queries on top of the data set, and the data set is copied to your local report, let's say it like that, it's also optimized to go column by column, okay? And again, over here we have some verti-scan also done, but at the data set level, because the tables that we use in Power BI data sets are the tabular models, so each column has its own values, and we only look at those specific columns. When we go to the direct lake, instead of doing that at the data set level, we do it at the Delta Parquet files, okay? So in direct query mode, the middle image on Snowflake, you would have columnar queries. Why would Verti on Parquet be faster? So when we are talking about direct query mode, we don't have columnar queries. We have SQL queries. So we go to the traditional format of the scanning. Okay. So this middle one, we are transforming our DAX queries into SQL queries. So we get from a specific one saying, okay, pick up this specific column, these two specific columns, and we get to select column A from table B with aggregation of year, month, whatever. And the conversion between these two types of queries takes longer, so it's slow. When we are at the bottom one, this is not converted. So as I said, what happens is that automatically these DAX queries are optimized by the VertiPack engines to just pick up those specific columns. So there is no select from, there is only go to column A and go to column B, okay? Hopefully I addressed the question, okay? If you don't have any further questions, let me just share my contacts. So you can reach out through email, no problem. Also at our link website, also on LinkedIn. So if you have any questions, if you need any help, not only in developing your data platform, but also if you have some ad hoc questions, please reach out. We can help you in any way. So as we did this webinar, we are also doing others in the future. So feel free to reach out, and also be aware of our LinkedIn posts and our webpage, where we also introduce not only these webinars, but also the workshops that we have for FAIAD in a day, for example, and all of the other all the other Microsoft policies, all the other Microsoft events that they have. Okay. Once again, thank you for your to join us, and feel free to reach out. Okay. Thank you.